In this video, we're going to do an example problem in biostatistics where we're going to use the chi-square goodness of fit test. We are testing how well what we observe fits with what we would expect under null hypothesis. Now, as always, I do these problems with pen and paper, but stick around to the end because you'll see me use ChatGPT just to do the problem for me. Now, leave a comment down below. Tell me how you feel about using ChatGPT or another large language model as far as helping you to learn or to verify your work. Let me know about it. And so there we go. Let's have a look at this problem. The proportion of students majoring in mathematics, physics, chemistry, and biology at a university is thought to be 0.2, 0.3, 0.25, and 0.25 respectively. After the first year of the COVID-19 pandemic and a move to online education, researchers claim that the proportions have changed. They collect data from 200 random students at the university and record the following frequencies: 45 for math, 55 for physics, 52 for chemistry, 48 for biology. So these are just simulated numbers. So verify the researcher's claim given the data above using a 5% level of significance. And so let's go about doing this. Remember, I use the 7 steps of hypothesis testing, but I always include an extra step, my step 0, that I just want to write out these things. So we are told that they went out and they randomly selected 200 individuals. So I'm going to put n equals 200. And let's look at these. I'm going to have P, 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 P. And then let's look at what these were under the null hypothesis. I'm going to put P subscript math. I think what's the first group? Then physics. What else did we have? We had chemistry and biology. So we were told what these values were. So let's say that under the null hypothesis, I'll put comma 0, comma 0. You can use the notation that you find in a textbook that you particularly like. It really doesn't matter as far as I'm concerned. So under the null hypothesis, these were 0.2, 0.2, 0.3, 0.25, and 0.25. Now we have a sample size of 100, so what would our expectation be? Now let's make these 1, 2, 3, 4, the 4 categories for this categorical variable. What is your major? So if I expect 20% of the population to be math majors, and I have 200, so 200 times 0.2, that would be what I would expect, and that gives me 40. So out of 200, if I expect 20%, so 20% of 100 is 20, but I have 200, that's 40. So I would expect 40 there. Here I would expect 0.3 times 200, that gives me 60. 25% of 200, well, that gives me 50. And this would be 25% out of 200 again, that gives me another 50. These are my expected values. So I'm going to say expected 1, expected 2, expected 3, and expected 4. So I've done a little bit of homework already there. And what did we observe? So let's put the observed here again. 01, 02, 03, 0 subscript 4. And if we look at these, what were they in the problem that we were given? So 45, we had 45, we had 55, that's what we observed, and 52 and 48. 52 and 48. So for a chi-square goodness of fit test, how well does what I observe, how well does that fit with what I expect? A goodness of fit test. And then we were also told to use an alpha value of 0.05. So that's great. Let's get going with our problem. Step number 1, we want to know what are the population parameters of interest. So the population parameters, so I've written the population parameters are the proportion of the students who major in these for math, physics, chemistry, and biology. And again, this is just a silly little made-up problem. And what we just imagine that if we look at all these undergraduate students forming this whole population, and then we just randomly selected 200 and looked at these observed values. So in step number 2, we're going to write the null hypothesis. And the null hypothesis, we're going to see that math, that proportion is 0.2. And we have for physics, that's 0.3. And for chemistry, 0.25, and for biology, 0.25. So under the null hypothesis, these are the proportions that I think in the population. Note that I don't put the comma 0 there necessarily. I think it's better just to write this. It's just referring to, in the larger population, this is what we think the proportions are. And then my alternative hypothesis, I'm going to be very lazy and say not H sub 0. So that those are not the proportions. Great stuff. Let's do step number 3. We're just going to write again lazily that alpha equals 0.05. Our level of significance is 0.05. And let's look at step number 4. What test are we going to use? Well, we were told to use the chi-square GOF, goodness of fit. It's you'll see that abbreviation there, and I'm just going to be lazy and use that. So why can I use this? What's the assumption? Well, our variable here has a nominal level of measurement. I can't do this if that was numerical data. So that's your question, and you can you have a single variable, and there's the sample spaces, either math, physics, chemistry, or biology. We are going to assume that these are all independent and identically distributed. And so the important part there for me for this course is just to know that these are all independent. And of all these 200 people that was randomly selected. So we have those. One thing we still have to look at is that the expected values are 5 or more. And so I have to look at the expected values. And we really don't want any one of them to be very close to 0% or 1%. And these are our expected values, or the proportion of any one of these to be near 0, 100. But if I look at my expected values, 40, 60, 50, 50, all of them are 5 or more. So I really have no problems in using this chi-square goodness of fit test. So let's do step number 5. What is our test statistic? How is it described? Well, let's do it in green because these are my equations. So I'm going to say that x squared is described by the chi-squared distribution on a given degree of freedom under the null hypothesis. And in this instance, we have to just look at our degrees of freedom. That's going to be k minus 1, where k is the number of categories in our variable, our nominal variable, and we have 1, 2, 3, 4. And so for us, nu is going to be 4 minus 1, that equals 3. And if we look at then, we're going to say that x squared is described by the chi-square distribution on 3 degrees of freedom. Remember, that is only under the null hypothesis. So if the null hypothesis was true and these were the proportions, and I went and I took 200 people at random and calculated an x square, and I do it over and over and over and over again, assuming that this is what it looks like, I will get a bunch of x squared values, and they will follow this chi-square distribution on 3 degrees of freedom. So now we have to just calculate our x squared statistic. So I'm going to say x squared equals, and I want to do this, and I'm just going to go back and forth, or maybe I should just try and hold open this page. So it's observed minus expected. So I'm going to have observed 45, I expected 40. I'm going to square that and divide by 40, plus I move on to the next one, 55, I expected 60. So that's 55 minus 60 squared divided by 60, plus then I'm going to go 52 and 50. Observed 52, expected 50, square that, divided by the expected, which is 50, and then these final two, 48 and 50, so that's going to be 48 minus 50, square them, and I'm going to divide by what I expected 50 there under the null hypothesis. So let's try neatly and put lines there without smudging this wet ink. Love my fountain pens, but they do smear. There we go. And now I can do all of that, and I calculate an x squared value. If I use my calculator, I get about 1.202. That's my one single x squared values, but remember that's one out of an infinite many that I could do if I could do my study an infinite number of times over and over again. So in step number 6, we have to make a decision. So we need the critical value, chi-square critical. And you can use your spreadsheet software for that, just to calculate these values. And you have to specifically use 5% level of significance, and you have to use 3 degrees of freedom. And that's going to be around about 7.8. We don't have to do too many decimal places. And we would say we would reject if x squared was larger than this chi-square critical value. And we see 1.02 is not larger than 7.8. It's not larger. So we're going to say we failed to reject the null hypothesis. Failed to reject the null hypothesis. So we can write step number 7. And we're just going to say, I'm going to write it out, and I'll forward the video so you don't have to watch me writing. I've written there's not enough evidence in the data at the 5% level of significance to show that the population proportion of students who major in math, physics, chemistry, and biology following the pandemic is not 0.2, 0.3, 0.25, and 0.25 respectively. So that's it for this problem. Let's have a look at what ChatGPT makes of this problem. So I'm in ChatGPT. As you can see, I'm using the O3 Mini High model. By the time you watch this, we might be at ChatGPT version 10 million. Who knows? I've got 0.3 mini here. It's a bit of overkill for this problem, but that's what I've chosen. So I have typed the following. So this bit is me copying and pasting the problem, but I've prepended it by saying, help me with the following biostatistics example problem. I've pasted in the problem as you've written, as you've already seen. You will notice me when I put anything that's remotely mathematical, I put dollar symbols around it, no spaces. That's LaTeX or LaTeX. That's specific mathematical notation. If I want to put in an equation, I can, and I do find, and I will always maintain that the OpenAI models, ChatGPT, is very good at reading this mathematical typesetting, and for me it's much better than some of the other models. So I have also added the following: generate a solution to this problem using the following 7 steps, and I outline the 7 steps that we use. So let's have a look at this. Let's look at what ChatGPT said about the population parameters. The parameters of interest are the true proportions of students majoring in math, physics, chemistry, and biology, and it's done its notation for those 4. The hypotheses are these values as stated under the null hypothesis, and the alternative hypothesis, at least one of the proportions is different from the claimed values. Now, of course, if one changes, automatically one of the others has to change. So it's actually 2 or more of them would be different, but that's a bit pedantic. Level of significance, 0.05, that's fantastic. The statistical test, we can use a chi-square goodness of fit test. And it says the assumptions, the data are random and independent samples. The categories are mutually exclusive. The expected frequency in each category should be at least 5. And it calculates them there. What would it be if 20% are majoring in mathematics and I have 200 people? 200 times 0.2 is 40. 200 times 0.3 is 60. 200 times 0.25 is 50. 200 0.25 is 50. Of course, if you sum those, it has to come to 200. But look at that. We have at least 5 of each. So that's fine. There's our test statistic, how to calculate it. And it's done all of that, 45 minus 40 squared over 40, 55 minus 60 squared, and it's summed over all of those. And it also got 1.202. So that's great. And then under the null hypothesis, 4 minus 1 is 3. So I'm happy with that. The decision rule for alpha equals 0.05 and 3 degrees of freedom, the critical value is approximately 7.815. There's our decision rule. If x squared is, as we calculate, or from the data, is more than the critical value, we'll reject. We had 1.202. That's not larger than. In fact, that's smaller than 7.815. So we failed to reject. And so at the 5% level of significance, there's insufficient evidence to conclude that the proportion of students majoring in math, physics, chemistry, and biology have changed from the originally stated values. So I think 100% for ChatGPT here, and I encourage you to use it. Of course, as always, I trust that you use this properly. I know as an adult, you will not cheat yourself by allowing yourself to copy and paste these solutions. You miss out on your own education and learning these things. And that's just not the way to go. You have to have, and I believe you do, an interest in this, and you will try and do these problems yourself. But it's wonderful to see, ChatGPT work at the problem and to confirm that your results at least are correct. Although always remember, it says here at the bottom, ChatGPT can make mistakes. But I do truly think that the probability that you and ChatGPT make the exact same mistake is probably not very high. And in an education setting, I think this is absolutely fine. So I went ahead and I did something else. I said, thank you. Create a plot of the chi-square distribution. And there's my LaTeX for chi-square. And so again, as always, if you want a video on mathematical typesetting using LaTeX, if you're in any kind of data science world and you have to create a report and you want beautiful mathematical typesetting, if you want to write an equation, let me know in the comment down below. in the comment section down below, and I can create that video for you. So I just want a plot showing the region of rejection for 5% level of significance, and add a marker to show the test statistic value of 1.202 as we've calculated. And ChatGPT comes back and it's written some Python code for me as always. There's a little copy button, and I'm just going to copy and paste the solution. And there we go. It's a bit small. It's just copy and paste. You can look at the code in the previous section of ChatGPT. So this is in a Google notebook, Google Colab notebook. And so that's part of Google Docs, Google Sheets. If you have Google Drive, you have access to this. You don't have to install Python on your own. You just open, like you open a new Google Doc or Google Sheet. You just open a Google Colab notebook, and you can just copy and paste the Python code right in here, and it's going to execute the code. You don't have to install anything. Once again, if you want videos on this, write to me down in the comment section. So there's all the code. I've copied and pasted it, and there is our beautiful plot. Have a look at it. I think it's fantastic. And there we go. We see the chi-square distribution on 3 degrees of freedom. We see the region of rejection above our critical value. And we see that blue dotted line. That is where our test statistic is. And that's clearly one of the 95% most probable x-squared values under the null hypothesis. It's certainly not one of those 5% least probable in that region of rejection that we see in the upper tail. So clearly we failed to reject the null hypothesis. So that's another problem done. I'm sure you enjoyed doing these problems, at least as much as I love putting them out there. Again, leave me a comment down below. What is your feeling? Do you use ChatGPT or one of the other models? If you use one of the other models, why do you use that? Let me know your use cases. I'm always interested to learn more.